Let's learn how to work with polar form of a complex number. Suppose if there is a point in a Cartesian plane, okay, we can say that if I draw a line like this, suppose this is x and this is y, this point is all denoted by xy. Now if you have a line which I am putting it over here, okay, in case of complex numbers you can say that this is x comma I y. Okay, suppose if you draw a line like this and if I denote this as s, you can, and this angle is mentioned as theta, we can say that, like we can find out the trigonometric coordinates, which is like sine theta is equal to y over r, or y is equal to r sine theta. And if you take cos theta is equal to x over r. So x is equal to r cos theta. So I'm getting two other values for x and y, which means that x plus iy, the Cartesian coordinates of that point, can be written as r cos theta plus I r sine theta. Or I can take r outside, writing it as cos theta plus I sine theta. Okay, so this is the polar form of a complex number x plus iy, where theta is the angle between the x-axis and the line. Okay, now also from this diagram we can say that r is equal to square root of x square plus y square, working with the Pythagoras theorem. And also if you take tan theta, you can say that it is y over x, and theta is equal to tan inverse y over x. Okay, so this information, these two information will help us in converting values from the Cartesian coordinates, which is like x and iy, or x plus iy, to the polar form, which is r cos theta plus I sine theta. Okay, so let us write that the Cartesian form of a complex number is x plus iy. Okay, and the polar form, or it has another name called modulus argument form, that is r cos theta plus I sine theta. Now how do you convert it between these two? That is with the information r is equal to square root of x square plus y square, and also theta is equal to tan inverse y over x. Okay, let's take an example and see how we can work this equation out. Suppose if you have a polar form of a number Z1, which is nothing but 12 into cos pi over 6 plus I sine pi over 6. Now for this equation, or this complex number, we need to find the values of cos pi over 6 and sine pi over 6. So you need to write it into the form of x plus iy. So what you do is you find the values of this. So cos pi over 6, the value will be root 3 over 2, and sine pi over 6, the value is 1 over 2. Okay, you can get it from the formula table, or you can use the calculator. Now we can write Z1 is equal to 12 times root 3 over 2 plus I 1 over 2, that is equal to 12 times root 3 over 2, I am just multiplying it, plus 12 times I times 1 over 2, which is equal to 6 root 3 plus 6i. So this is of the form x plus iy, or I6, whatever you can write it in any form as you need. So x plus iy. So we have written it into the form of a complex number in the Cartesian form. Okay, so this is polar form to Cartesian form. So you have the polar form, you are converting it into the Cartesian form. Now we are moving to Cartesian to polar form. So Cartesian to polar form, so we have a complex number which is minus 1 plus I root 3. You need to write it in the polar form. So what I can do is I can first draw a the diagram for the complex number, minus 1 plus I root 3. So this is the real part and this is the imaginary part, and we know this is the real axis and this is the imaginary axis. So the imaginary axis root 3 will come here, and on the real part minus 1 will come here. So the point will come somewhere around here. Okay, so I'm just joining this line, and this is the complex number. So this is the complex number 1 minus 1 plus root 3I. Okay, and now we know that this is the angle which we have to find out. Okay, also I would like to extend this line here, because whenever we work on the values of the polar form, we might get the values of the negative value. So this will be some sort of a negative value, and if that is the case, you can find this positive value by subtracting it from pi minus whatever suppose if this value is x, whatever value you get it over here, that will be the positive value. Okay, so for the time being, we are just mapping it into the diagram and we are just moving forward. So to write the polar form, it is r times cos theta plus I sine theta. So you need to find r, you need to find theta, and for that we will use the formula r is equal to square root of x square plus y square. That is nothing but square root of minus 1 square plus root 3 square, which is equal to square root of 4, which is equal to 2. Okay, and to find theta, what you will do, it is tan inverse y over x, that is equal to tan inverse root 3 over 1, that is equal to minus pi over 3. Okay, so minus pi over 3 means it is the value which we got over here, so it is like minus pi over 3. So I'm just, for the time being, I'm just removing this one. And since this is minus pi over 3, this value which I am marking over here will be pi minus pi over 3, that is equal to 2 pi over 3. So in our case, the angle is 2 pi over 3. So in our case, the angle is 2 pi over 3, because it is with the graph, we know that it is a positive side of the axis. So now I can write the polar form coordinate as r cos theta plus I sine theta can be written as 2 is the r, value of r, and cos 2 pi over 3 plus I sine 2 pi over 3. Okay, so this is the polar form of the coordinate. So to convert from the Cartesian to the polar form, we need to find the value of r and also find the value of theta, and then substitute it into the equation. Okay, now there's one small thing what you have to understand here, where you have the Cartesian coordinates, Cartesian plane here, and if the line is somewhere like this, the tan ratio will be negative here in the second quadrant. So this is the second quadrant. Also it will be negative in the fourth quadrant. Okay, and tan will be positive in the first quadrant and the third quadrant. So understanding this, you will be able to map the diagrams and map the values in a much better manner. Okay, so let's see some more questions out here. Let's take an example of writing from polar form to Cartesian. That is pretty easy. So if you have root 2 into cos 3 pi over 4 plus I sine 3 pi over 4, what you need to do is you need to find the values of these pi over 3 pi over 4, and then you can directly substitute it into the values. So in this case, it is square root of cos 3 pi over 4. You will get minus root 2 over 2 plus I sine 3 pi over 4 will also be root 2 over 2, and then you simplify this where you will get minus 2 over 2 plus 2 over 2i. So that is equal to minus 1 plus I. So it's pretty easy. Okay. Now the second option is Cartesian to polar. So remember, when you need to move from the Cartesian to polar, you find r using the formula r is equal to square root of x square plus y square. and then theta using the formula tan inverse y over x. So this is one thing which you have to remember. Now you can, let's take an example. 2 plus 2i, the complex number is 2 plus 2i. So now first thing is you have to find the value of r, which is like 2 square plus 2 square, which is equal to square root of 8, which is equal to 2 root 2. Okay. Also the argument will be tan inverse y over x, that is nothing but tan inverse 2 over 2, which is equal to pi over 4 radians. Okay. Now you can plot this also in the diagram. So here the diagram will be 2 plus 2i. So it is like 2, and here it will be 2 and 2. This is the real part and this is the imaginary part, and so the one will come here. So this the line will be like this. The point is this. So 2 plus 2i is the point, and the theta is nothing but pi over 4, and the modulus is root 8. So this distance r is equal to root 8. Okay, we'll do one more question here. Z is equal to 4. Okay, when you take, when you have a number like this, it actually means that 4 plus 0i. You have to always remember that. So in this case, r will be equal to square root of 4 square, which is equal to 4, and the argument tan theta will be equal to y over r, or theta is equal to tan inverse y over x, tan inverse y over x, that is equal to tan inverse 0 over 4, which is equal to 0. This is also radians. Okay, so there's no angle here. So if you want to put it in an Argand diagram, so what you will say is like 4 plus 0i, so which means the real part and the imaginary part. The real part is 4, and there is no angle, so which means the complex number is this one. Okay, which is 4, which means 4 plus 0i. Okay, and let me just note down the number like this, like so that I can mention the argument. So modulus is equal to 4, r is equal to 4. Okay, now let's work with a little more different ones. Same with polar coordinate, Cartesian coordinate to polar coordinate. So 1 plus I. Now same process, r is equal to square root of 1 square plus 1, which is equal to 1 square plus 1 square, which is equal to square root of 2, and theta is equal to tan inverse 1 over 1, which is equal to pi over 4. So z is equal to r cos theta plus I sin theta, that is equal to root 2 times cos pi by 4 plus I sin pi by 4. It's pretty easy. And even if you want to chart a diagram, the point will be 1 plus I. This will be the point. The modulus is root 2. Okay. Now let's take the case where we get a negative number. So that is z is equal to minus 2 plus square root of 2i. So you can actually chart the diagram initially so that you will understand where it will come. So minus 2, this is the real part and this is the imaginary part. So minus 2 will come somewhere here, and root 2 will come maybe somewhere here. So this is the point, this is the complex number, and I am just marking it here, and I will bring it here. So this value is theta from the positive direction of the x-axis, and you will get a different number here, which will be the negative value. Okay. So for this case, what I'm going to do is like I'm going to find r, so which is like minus 2 square plus root 2 square, which is equal to square root of 6. I'm sorry. Root 2 square is, that's not square root of 6. Square root of 2 square is minus 2 square is minus 2. No, sorry. 2 square plus square root of 2 square. Yeah, okay. So minus 2 square is 4, correct. 4 plus 2, which is equal to 6. I'm sorry about that. So it is square root of 6. And theta is equal to tan inverse y over x. So that is equal to tan inverse root 2 over 2, which you will get it somewhere around minus 35.3. This is gotten from the calculator, so I've done it before. Now since this is the value minus 35.3 minus 35.3. So if you need to find the value of theta, so theta means it is the negative value. So for finding the actual theta, you need to subtract it from pi minus 35.3. So pi, in the sense when it considered it in degree, it is 180. So the answer is actually 180 minus 35.3. So which is equal to 44.7 degrees. So in this case, Z will be R cos theta plus I sin theta, which is equal to root 6 into cos 144.7 plus I sin 144.7 degree. You can find the values of this, but that is not required. When you need to write in the polar form, you can just directly write only the degrees, and you can just leave it like this. We'll do one more problem. Z is equal to minus 5. So in this case, same like this, we can draw an argand diagram. So minus 5 will come somewhere over here, and this will be this one, and the theta will be this angle. So you'll find R is equal to minus 5 square. As I said, this will be minus 5 plus 0 square, that is equal to 5, and theta is equal to tan inverse y minus x. So it is 0 over 5, which is equal to tan inverse 0, which is equal to 0. Okay, so now in this case, you need to find out 180 minus 0, that is nothing but 180 degree itself, that is equal to pi. Okay. So in this case, R is equal to 5 cos pi plus I sin